Welcome to Notes 9.4, Essential Skills Z4, Evaluating Limits Graphically. Much of this is going to be a repeat and a refresher of what we did in trimester 1 with limits. First, the notation. This is how we read it. This is not the actual definition. The definition is complicated, so this is just an informal way to think about it. The limit of f of x as x approaches c is L. Informally, we're going to look at what happens to f of x or y as x gets closer to c. To illustrate how a limit is different from simply evaluating a function, we can look at this graphically. F of 1. If we just ask what is f of 1, we're saying what is y when x is 1. In this case, we have an open circle on the graph, which means there is no value at x equals 1. There's no y value. DME is our abbreviation for does not exist. If we turn this into a limit question, here's how this changes the question we ask. Our answer, if we look at points near where x equals 1, y gets very, very close to -1. That is what we mean by the limit. We have another way of exploring y values if we have a calculator available. We can simply plug in the value of x or values near what x is approaching and read off the y values. In this case, x is getting close to 2. So let's take a look. I put the calculator in trace mode so that I can see what happens as x gets close to 2. As you can see, if I put in 2 directly, we don't have a y value. But we can clearly see that there are values nearby. We can get even closer if we want more precision. We worked a little bit in trimester 1 with asymptotic and one-sided limits. To refresh, we have a left side limit and a right side limit. The difference is that little minus sign and that little plus sign. For our first example, x is approaching -1 from the right. Y is increasing without bound, and so we indicate that with an infinity sign. For the second example, x approaches -1 from the left. Again, y is increasing without bound as x gets closer to 1, and so the limit we write with an infinity sign. The general limit, x approaches -1 with no plus or minus, depends on the left and right sides. If the left side and the right side limits are the same, then the general limit is the same. We contrast that with the right side. X is going to approach 3 from the right in the first example. As x gets closer to 3 from the right, y increases without bound. Again, our limit is infinity. As x approaches 3 from the left, the corresponding y values are now dropping. We write that as -infinity. To determine the overall limit, we ask, does the left side limit equal the right side limit? The limit does not exist. We can also look at asymptotic limits with horizontal asymptotes. If x is headed toward infinity, we're looking at the right side of the graph. We're saying, what does y do as x gets bigger? In this case, there's a horizontal asymptote that indicates that the end behavior is going to stabilize over time. Y is going to get closer and closer to -1. As we look at the left side, you can see that x is approaching -infinity. This indicates we're looking to the left. Our y-coordinate, as indicated by the horizontal asymptote, is going to approach the y value of that asymptote. We can look at left and right-sided limits in terms of piecewise functions. We're often concerned with whether the pieces of a piecewise function will join together. Remember that when we find a limit, we're looking for a y value. The left-sided limit is on the left side of what x is approaching. Remember that when graphing a piecewise function, we must always obey the vertical line test. This is a function. The vertical line test must hold. Graphically, we ask the same questions. As x gets close to 1, coming from the left, what does y get close to? The left side and right side limits do not match. Therefore, this limit does not exist in general. The left side and right side limits match, and so the general limit is going to take the same value. The general limit may be a little bit surprising. If the left side limit is 1 and the right side limit is 1, that's all we care about when we find the general limit. It doesn't matter that the actual function value is 5. Please pause the video and try these exercises. I'll fill in the answers in a moment. Thank you for watching.